welcome to Conscious Frequency. Settle into this space, a sanctuary for exploration where the cosmos whispers its secrets. Here, we invite you to gently drift into the profound, the beautiful, and the deeply resonant. Tonight, we embark on a journey into the very essence of existence, exploring the microscopic dance of molecules that form the foundation of our reality, and how this dance echoes in the quietude of a vast, silent universe. We'll ponder the possibility of dreaming molecules, not in a literal sense, but as a metaphor for the inherent potential, the subtle energies, and the emergent properties that arise from the fundamental building blocks of everything. Prepare to be lulled into a state of wonder as we connect the quantum realm with the landscapes of our own consciousness. As you settle in, wherever you are in the world, feel the ground beneath you, the air around you. Are you nestled in a cozy chair, or perhaps preparing for a peaceful slumber? Let us know in the comments below where you're joining us from tonight. This shared space, though vast, becomes intimately connected through our collective presence. If these explorations of science, philosophy, and the mysteries of consciousness resonate with you, consider joining our growing family. A gentle tap of the subscribe button and the notification bell ensures you won't miss our future voyages into the sublime. Your support helps us continue to cultivate this tranquil haven of knowledge. Over the next 2.5 hours, we will unfold 25 chapters, each a gentle step deeper into the universe's quiet hum. Allow your breath to deepen, your muscles to relax. Let go of the day's distractions and allow the narrative to wash over you. This is your time to simply be and to explore. We begin not with a bang, but with a profound stillness, the canvas upon which all of reality is painted. Think about it for a moment. Before the stars ignited, before the galaxies began their slow, graceful waltz, there was this deep, pervasive quiet. It's a stillness that stretches beyond our wildest imaginings, a silence that hums with an ancient, unspoken promise. It's easy to look at the vast expanse of the cosmos and feel a sense of emptiness, a profound absence. But what if that absence is, in itself, a kind of presence? What if the near, absolute vacuum of space isn't a void, but rather the very foundation of everything? It's like the space between your breaths, that tiny, almost imperceptible moment of nothingness. Without it, there's no room for the next inhale, no space for life to unfurl. The universe, in its grandest scale, seems to echo this same principle. This immensity of absence is as fundamental as any star, any planet, any particle we can ever perceive. And then there's the silence itself. We often associate sound with vibration, with the air molecules dancing and colliding to carry a message to our ears. But out there, in the cold, dark vacuum of space, there's no air, no medium for those vibrations to travel. It's a silence so absolute, it's almost a physical thing, a blanket of quiet that wraps around everything. This cosmic silence shapes our perception of the universe, doesn't it? It forces us to look, to feel, the presence of things without the constant chatter of sound. It's a silence that allows us to hear the universe in a different way. Through the language of light, of gravity, of the subtle shifts in energy that ripple across unimaginable distances. It's a silence that invites a different kind of listening, a listening with the soul. But here's where it gets truly fascinating. This seemingly empty, silent space isn't quite as empty as it appears. Beneath the surface of this profound quiet, there's a vibrant, energetic undercurrent. Scientists talk about quantum fields. Imagine them as invisible, all-pervading oceans of potential, woven into the very fabric of existence. These fields are the true fundamental reality, the unseen substrate from which everything else emerges. It's not that space is empty, it's that it's teeming with these fundamental fields, like a perfectly still pond that's actually alive with countless microscopic organisms, each holding the potential for life. These fields are the silent symphony, the underlying hum that orchestrates the entire cosmic dance. And from these seemingly inert, silent fields, complexity arises. It's like a magician pulling a rabbit from a hat, but the hat is the universe, and the rabbit is, well, everything. These quantum fields, in their inherent potential, begin to fluctuate. Tiny ripples appear, like disturbances on the surface of that still lake. These fluctuations are the first whispers of existence, the nascent stirrings of what will eventually become matter, energy, the very stars and planets we see. It's a process of emergence from stillness, a testament to the latent power held within the quiet. Think of it as the universe dreaming itself into being, a gentle unfolding from a state of pure, unmanifested possibility. Imagine the universe as a vast, perfectly still lake. The silence isn't emptiness, but the potential for every ripple, every wave, to begin. But what are these foundational fields made of? And how do they begin to dream into being the matter we know? Close your eyes for a moment if you can, and imagine the deepest silence you can possibly conjure. Not just the absence of noise, but a profound, all-encompassing quiet. What does that silence feel like? Does it feel hollow, or does it feel full of a quiet, waiting energy? Let that feeling settle within you as we continue our journey. And so, from that silent, shimmering ocean of fields, we begin to perceive the first subtle stirrings, the nascent whispers of existence. It's as if the universe itself is taking its very first, tentative breaths. This is where things get wonderfully strange and frankly, a little bit magical. Imagine the vacuum of space, that seemingly empty void. It's not truly empty, is it? It's teeming with a kind of potential, a latent energy. And because of this peculiar rule, the Heisenberg uncertainty principle, energy isn't as constant as we might think. It can, for the briefest, most fleeting of moments, just pop into existence, and then just as quickly, vanish back into nothingness. Think of it like a tiny spark that ignites and dies before you can even properly see it, a momentary flicker of being in the vast expanse of non-being. It's energy borrowing itself, just for a blink. And these borrowed moments, these energetic blips, they often manifest as virtual particles. Imagine tiny ephemeral partners, a particle and its antiparticle, appearing together like a fleeting embrace, only to annihilate each other almost instantaneously. They're like ghosts of particles dancing in and out of reality, a constant, jittery ballet happening everywhere, all the time. They don't have a long, stable life, you see, but their presence, however brief, is incredibly significant. They're the universe's way of playing with possibilities, testing the waters of what could be. Now, to give these fleeting dancers a bit more substance, a reason to stay for a moment, we need to talk about the Higgs field. This field is like a cosmic molasses, a pervasive, invisible substance that permeates everything. When fundamental particles, like electrons or quarks, move through this field, they interact with it. And this interaction, this subtle resistance, is what gives them their mass. Without the Higgs field, these particles would just zip around at the speed of light, never quite settling down, never forming the stable building blocks we know. It's the Higgs field that gives them their heft, their inertia, their very sense of being something rather than just pure energy. So, in those very first, fiery moments after the Big Bang, as the universe cooled and expanded, these excitations in the quantum fields, these energetic ripples, began to coalesce. The virtual particles, the momentary flashes of energy, started to find a more stable footing, and as they interacted with the Higgs field, they gained mass, becoming the first actual particles. This was the dawn of matter, the very first ingredients for everything that would ever be, stirring from the primordial soup of fields. Think of the quantum field like a vast, invisible trampoline. When it's disturbed, ripples appear. These are our particles. These fleeting particles, born from the energetic hum of the fields, are the first actors on our cosmic stage. But what compels them to bind together, to move beyond mere existence and begin to dream of molecules? As these tiny sparks of existence, these nascent particles, begin to gather a kind of substance, something truly magical starts to happen. It's as if invisible threads, finer than any silk, begin to weave themselves between them, dictating their every interaction, their every move. It's a silent choreography, a cosmic ballad of attraction and repulsion. And at the heart of this intricate dance, we find the four fundamental forces. Think of them as the universe's primary conductors, each with its own unique tempo and melody. There's gravity, that gentle, universal hug that pulls everything together, from the smallest dust mote to the grandest galaxy. Then there's electromagnetism, the spark that ignites stars and paints our world with color, a force that governs everything from the glint of sunlight on water to the very bonds that hold our bodies together. And deep within the heart of atoms, we have the strong nuclear force, a tenacious grip that binds protons and neutrons, preventing the nucleus from flying apart. Finally, there's the weak nuclear force, a more subtle influence, responsible for certain types of radioactive decay, a quiet whisper that can transform one element into another. Now, how do these forces actually communicate? They don't just reach out and touch like we might. Instead, they use a special kind of messenger, a particle called a boson. Imagine these forces as conversations, and the bosons are the words being exchanged. Photons are the carriers of the electromagnetic force, like little packets of light zipping back and forth, allowing charged particles to talk to each other. For the strong nuclear force, there are gluons, aptly named because they glue quarks together within protons and neutrons. Then you have the W and Z bosons, carrying the weak nuclear force, involved in processes like nuclear fusion. And for gravity, the theoretical messenger is the graviton, still a bit shy and elusive, but believed to be the spark that carries gravitational influence. Let's linger for a moment on the electromagnetism, that familiar everyday miracle. It's the force that dictates how electrons orbit atomic nuclei, like tiny planets around a sun. It's what allows atoms to link up, to form molecules, the very essence of chemistry. When you see a rainbow arching across the sky, or feel the warmth of the sun on your skin, you're witnessing the electromagnetic force in action. It's the force that allows us to see, to hear, to touch, to taste, to smell. It's the invisible architecture of our sensory experience, the vibrant thread that weaves through the fabric of our reality. Then we delve into the atomic nucleus, the dense, energetic core of matter. Here, the strong nuclear force reigns supreme. It's an incredibly powerful, short-range force, like an incredibly strong, yet very localized embrace. Without it, the positively charged protons within the nucleus would repel each other violently, and atoms as we know them simply couldn't exist. It's the ultimate cosmic glue. And then there's the weak nuclear force. It's not as strong nor as far-reaching, but it plays a crucial role in shaping the universe. It's responsible for processes like beta decay, where a neutron can transform into a proton, an electron, and an antineutrino. It's this subtle force that allows stars to shine, powering the nuclear reactions that create heavier elements. So, you see, these forces are like invisible strings connecting the quantum actors on this grand stage. Some strings are incredibly strong, holding them tightly in place, like the strong nuclear force. Others are more fleeting, guiding their transformations and interactions, like the weak nuclear force. And then there's the pervasive hum of electromagnetism, and the gentle, ever-present pull of gravity. With all these forces at play, orchestrating their silent symphonies, the stage is truly set for the formation of the first atoms, the fundamental building blocks of everything we can perceive, and so much more. As you go about your day, perhaps take a moment to notice the light around you. That soft glow, that vibrant color, that variability to see, it's all a manifestation of the electromagnetic force, a constant, beautiful dance happening all around and within you. And so, from that incandescent, energetic soup, a subtle shift began. It was as if the universe, having danced in a chaotic frenzy, started to find its rhythm, its first stable structures beginning to crystallize. We're talking about the primordial elements, the very building blocks that would lay the foundation for everything we know, and everything we can't even imagine. Think of it, this incredible dance of protons and neutrons, zipping and swirling in that early cosmic plasma. As the universe cooled just enough, these positively charged protons and their neutral companions, the neutrons, found themselves drawn together by an invisible, yet incredibly powerful embrace. It was a process called nucleosynthesis, the universe's first act of cosmic metallurgy. Protons and neutrons, like eager dancers, began to fuse, merging their identities to form the very first atomic nuclei. It wasn't a violent explosion, but a gentle, persistent coming together, a quiet forging of essence. Imagine tiny, energetic sparks finding each other in the vast darkness, clinging together to create something new, something more substantial. This was the birth of the elements, a subtle alchemy happening on a scale so immense it's almost beyond our grasp. And what emerged from this initial cosmic forge? Primarily, the simplest of souls of hydrogen and helium. Hydrogen, a single proton, the universe's lone wanderer, and helium with its 2 protons and 2 neutrons, a slightly more complex, yet still elegantly simple, formation. They were the quiet majority, the first stable citizens of this nascent cosmos. Their atomic structures were so uncluttered, so pure, like the first clear notes of a cosmic melody. They were the fundamental whispers, the gentle beginnings of matter, unburdened by the intricate arrangements that would come later. Their abundance was staggering, forming the vast majority of what was then. But a nucleus, all alone, is like a song without an audience, a spark without a place to land. It's positively charged, a beacon of attraction. And out there, in that cooling expanse, were the electrons. These tiny, negatively charged particles, like curious fireflies, were drawn to the positive pull of the nuclei. This is where the magic of electron capture and Ars binding truly takes hold. As the universe continued its gentle expansion and cooling, these electrons, once perhaps a bit too energetic to settle, now found their perfect partners. They began to orbit, to dance around the nuclei, their negative charge perfectly balancing the positive charge of the protons. This wasn't a forced capture, but a natural attraction, a harmonious pairing that created the first truly neutral atoms. Imagine those first, simple nuclei as tiny magnetic hearts, and the electrons as the gentle breezes that found their way to them, settling into stable orbits, creating the first complete, self-contained entities. And these simple atoms, hydrogen and helium, they weren't just inert dust. Oh no! They were the seeds of structure. They were the fundamental molecules of the early cosmos, holding within their very being the blueprint for all future complexity. Think of them as the first perfectly formed Lego bricks, incredibly basic, yet possessing the inherent potential to be snapped together, to form intricate castles, soaring rockets, even delicate flowers. Each atom, a tiny universe in itself, a self-contained unit of possibility, waiting for the right conditions, the right cosmic nudges, to begin the grander dance of combination. It's almost like imagining the early universe as a vast, cosmic pot of soup, simmering with energy and potential. And then, as it began to cool, the first stable structures, the first atoms, began to crystallize. They were like simple, perfectly formed salt crystals settling at the bottom of the pot, distinct and pure, a departure from the uniform liquid that came before. But how did these simple, elegant atoms learn to combine, to weave themselves into the intricate molecular tapestries that would eventually give rise to life? That's the next whisper we'll chase. And as you breathe in, right now, feel that air filling your lungs. It's composed of atoms, the distant, evolved descendants of those very first primordial elements. A direct connection to the dawn of everything. And so, the universe, no longer just a scattered collection of cosmic dust, a silent, solitary dance of individual atoms, begins to hum. It's a subtle shift at first, a whisper on the universal breeze, as these fundamental building blocks discover a profound new language connection. They learn to reach out, to share, to resonate with one another, and in doing so, a new kind of harmony begins to bloom, a nascent symphony played out on the smallest of stages. This is where the molecular orchestra truly begins its overture, a grand performance driven by a fundamental yearning for stability. Atoms, you see, are a bit like lonely travelers, always seeking a more comfortable resting place. And the most elegant way they've found to achieve this is through something called chemical bonding. Imagine it like atoms finding their perfect dance partners. There's covalent bonding, where two atoms decide to share their outer electrons, like two friends sharing a secret, holding on to something precious together. Then there's ionic bonding, a bit more dramatic, where one atom generously, or perhaps a little desperately, gives an electron to another, creating a strong electrostatic pull, like tiny magnets drawn irresistibly close. And finally, metallic bonding, a beautiful communal embrace where electrons are shared freely amongst a whole crowd of atoms, creating a shimmering, conductive sea. It's this intricate ballad of electron sharing and transfer that allows the universe to weave itself into more complex forms. And at the heart of this molecular artistry, there's one element that stands out with remarkable grace: the carbon. Carbon is the maestro of the molecular world, the ultimate polymath of the periodic table. What makes carbon so special? It's its incredible ability to form 4 distinct chemical bonds. Think of it as having 4 hands, each ready to clasp another atom. This allows carbon atoms to link together in long chains, in rings, in branching structures, forming the scaffolding for an almost infinite variety of molecules. It's this versatility, this capacity for intricate molecular architecture, that lays the groundwork for the breathtaking complexity we see all around us, from the simplest sugars to the most elaborate proteins. Without carbon's four-handed embrace, the universe would be a far simpler, and perhaps a much quieter place. And then there's water. Water, it's more than just a drink, more than just a simple H2O. Water is the cosmic solvent, the gentle facilitator of life's grandest experiments. Its unique molecular structure, with its slightly positive hydrogen atoms and its slightly negative oxygen atom, makes it a phenomenal solvent. It's like a universal welcoming committee, able to surround and dissolve a vast array of other molecules, bringing them together, allowing them to interact, to react, to dance. Water's polarity means it can form hydrogen bonds with itself, creating a cohesive surface tension, a slight stickiness that allows it to climb up plant stems or form dewdrops that shimmer like tiny jewels. It's this remarkable ability to bridge gaps, to bring disparate elements into intimate contact, that makes water the cradle for so much of the universe's unfolding creativity. From these fundamental interactions, from these simple acts of sharing and attraction, a breathtaking complexity begins to emerge. We start with the most basic partnerships, like two hydrogen atoms forming a simple H2 molecule, a neat little duet. Then, with the help of carbon and the welcoming embrace of water, these duets evolve into trios, quartets, and eventually into vast, intricate symphonies. We see molecules like methane, a single carbon atom bonded to four hydrogens, a foundational building block. Then, carbon begins to link with itself, forming the backbone of organic chemistry, creating molecules that can twist and turn and fold into shapes of exquisite precision. It's a journey from the elemental to the elaborate, a slow unfolding of potential, a gradual weaving of the universe's tapestry. Think of atoms as individual musicians, each with their own unique tone and energy. Chemical bonds are the sheet music, the intricate instructions that guide them to play together, not in random noise, but in harmonious symphonies of molecules. Each bond is a note, a rhythm, a tempo that orchestrates the grand composition of matter. And as these molecular symphonies begin to play, as these intricate structures take shape, a question begins to stir in the quiet corners of existence. What happens when these molecular arrangements start to exhibit properties that seem almost alive? Now, I invite you to join me in a small, tangible experiment. Hold your hands together, just like this. Feel the connection between your palms, the subtle pressure, the warmth. This simple, intimate touch, this gentle resistance, is a tiny, earthly echo of a chemical bond, a reminder of the fundamental forces that bind the universe together, one connection at a time. And so we find ourselves, after exploring the grand architecture of the cosmos, peering into the almost impossibly small. But don't let their size fool you. These aren't just inert building blocks. These molecules, they don't simply exist. They communicate. They interact. They respond in ways that hint ever so softly at a deeper intelligence, a silent conversation happening all around and within us, a language spoken in shapes and vibrations. Think about molecular recognition. It's like a cosmic dance of intricate keys and perfectly sculpted locks. Each molecule possesses a unique three-dimensional shape, a specific arrangement of atoms, and a delicate distribution of electrical charges. These features aren't random, they are the very essence of its identity. When two molecules encounter each other, it's not a collision of blind forces. Instead, their shapes and charges are recognized. It's a precise fit, a gentle embrace. Imagine a tiny, exquisitely crafted key sliding into its matching lock, the tumblers clicking into place with a whisper of certainty. This specific binding is the foundation for so much of life's intricate machinery, allowing for the precise delivery of messages, the building of complex structures, and the initiation of vital processes. It's a fundamental act of connection, a testament to order at the most fundamental level. Then there are the enzymes, these incredible molecular facilitators. They are the tireless conductors of our biochemical orchestra, accelerating reactions that would otherwise crawl along at a glacial pace, or perhaps not happen at all. Enzymes are specialized proteins, folded into complex, three-dimensional structures with active sites, pockets of specific shape and chemical environment. When the right reactant molecules, the substrates, arrive, they fit perfectly into these active sites. The enzyme then gently nudges them, perhaps bending a bond, or bringing reactive atoms into close proximity, whispering encouragement to the chemical transformation. It's like a master craftsman who, with a few deft movements of their tools, can shape raw material into something beautiful and functional with astonishing speed. Without these molecular helpers, the very processes that sustain us, from digesting food to replicating DNA, would simply grind to a halt. And the complexity deepens with allostery and feedback loops. Molecules don't just react, they influence each other's influence. Allostery is the phenomenon where a molecule binding to one site on a protein can subtly change the shape of another site, altering the protein's activity. It's like a gentle tug on a thread that causes a whole tapestry to shift. This allows for intricate control networks. Imagine a series of dominoes, but instead of just falling, each domino, as it's nudged, can also change the angle or the force with which it nudges the next. These feedback loops create sophisticated regulatory systems, ensuring that cellular processes are finely tuned, responding to changing conditions with remarkable precision. It's a delicate, interconnected web of communication, a constant negotiation of states. This leads us to the very concept of molecular information. How is it encoded? It's in the sequence of amino acids that make up a protein, dictating its final folded shape. It's in the specific arrangement of bases in DNA, the blueprint of life. The structure and arrangement of molecules aren't just physical properties. They are carriers of meaning, of instructions, of information. Think of it like a language written in the very fabric of matter. Each arrangement of atoms, each bond, each subtle twist and turn, contributes to a message that other molecules can read and respond to. It's a silent, pervasive form of data, constantly being read and acted upon. It's almost like imagining molecules as tiny, intricate puzzles. When the right pieces with their specific shapes and charges fit together, a new function or a new message is revealed. Each successful connection is a small revelation, a piece of a much larger unfolding story. This intricate molecular communication, this dance of recognition and influence, seems almost like a rudimentary form of thinking or dreaming, doesn't it? What fuels this persistent drive towards organization, this inherent tendency to connect and create order? Let's bring this back to you right here, right now. Take a moment, if you will, to focus on your breath. Feel the gentle rise and fall of your chest, the subtle expansion and contraction. Each inhale and exhale is a profound biological event, a complex dance of molecules. Oxygen molecules, with their specific electronic configurations, are recognized and welcomed into your lungs. Carbon dioxide molecules, the byproducts of your inner workings, are gently released. It's a vital exchange, a constant, silent conversation happening at the molecular level, sustaining the very flame of your consciousness. This intricate ballad of molecules is the foundation of your being, a testament to the quiet, persistent intelligence that animates us all. Can the intricate dance of molecules within our brains truly give rise to the subjective experience of consciousness? It's a question that whispers at the very edge of our understanding, a riddle wrapped in the shimmering, ephemeral fabric of our own awareness. We've journeyed through the vastness of the cosmos, peered into the quiet hum of the universe, and now, we turn our gaze inward, to the microscopic theater playing out behind our eyes. It's here, in the bustling metropolis of our minds, that the magic, or perhaps the sheer, elegant physics, of consciousness takes root. Let's begin with the tiny couriers, the neurotransmitters. Imagine them as incredibly specialized messengers, each carrying a unique whisper of information. They're released from one neuron, like a tiny seed tossed into a gentle breeze, and they drift across a microscopic chasm, the synapse, to land on the waiting receptors of another. Dopamine, serotonin, acetylcholine, these aren't just chemicals, they're the very language of thought, the subtle nudges that guide our perceptions, our moods, our very sense of self. When these molecular whispers align, when they form coherent patterns, it's as if a symphony begins to play, a symphony that, somehow we experience as being alive. And what about the electrical currents? It's not just about chemical whispers, there's a crackling energy too. Think of ion channels as tiny molecular gates, opening and closing with exquisite precision. When these gates swing open, charged molecules, like sodium and potassium ions, surge across the neuronal membrane, creating a ripple, an electrical impulse. This is the swift, electric pulse of information, the lightning flash that travels along the intricate network of our neurons. It's this rapid-fire exchange, this cascading wave of electrical activity, that forms the underlying rhythm of our thoughts, the very pulse of our awareness. It's a dance of charged particles, a silent, energetic ballad that underlies every sensation, every memory, every fleeting feeling. But here's where the plot thickens, where the scientific inquiry meets the philosophical abyss, the binding problem. How do all these disparate molecular events, these individual electrical firings and chemical transmissions, coalesce into a single, unified experience of consciousness? How does the red of an apple, the sweetness of its taste, and the memory of biting into it all become one, coherent perception? It's as if billions of tiny instruments are playing their own unique notes, yet we hear a single, harmonious melody. This is the grand puzzle, the tantalizing mystery that scientists and philosophers have grappled with for ages. Where is the conductor of this molecular orchestra? And this leads us to the concept of emergent properties. Consciousness, it seems, isn't located in any single molecule or even any single neuron. Instead, it emerges from the sheer complexity of the network. Imagine billions of neurons, interconnected in an unfathomably intricate web, their molecular machinery working in concert. It's the collective behavior, the emergent phenomenon arising from the sheer scale and complexity of these interactions, that gives rise to consciousness. It's like the humidity in the air. You can't point to a single water molecule and say, there it is, the humidity. It's the collective presence, the way they interact, that creates the experience. Our brains are like vast, intricate cities, bustling with activity. Molecules are the messengers carrying vital dispatches, the traffic flowing along the neural highways, and the very infrastructure, the buildings, the roads, the power lines that allows for thought and awareness to flourish. It's a breathtakingly complex ecosystem, humming with life and information. If these molecules, these fundamental building blocks of our very being, are the stage upon which consciousness plays out, do they perhaps carry echoes of the universe's fundamental dream, a silent resonance from the cosmic dawn? Gently, now, touch your forehead. Feel the warmth, the subtle contours beneath your fingertips. Imagine the intricate molecular ballet happening within, the unseen dance of neurotransmitters and ions, the silent hum of electrical signals, all conspiring to create you. The source of your awareness, your unique perspective on this quiet universe, is playing out right here, in this extraordinary, microscopic realm. It's a profound thought, isn't it? That the vastness of existence might be mirrored in the intricate workings of our own minds. If consciousness arises from the intricate dance of molecules, from the whisper of atoms bonding and unbonding, then can we dare to ask if the entire universe itself, this vast, starry expanse, might be seen through a similar lens? A lens of molecular purpose, perhaps, or even molecular dreaming? It's a thought that tickles the edges of our understanding, isn't it? Consider the grand architecture of the cosmos. Galaxies, those swirling celestial cities, are nothing more than colossal congregations of stardust, gas, and dark matter, all held together by the same fundamental forces that govern the tiniest molecular interactions here on Earth. Stars, those burning hearts of the universe, are giant molecular furnaces, fusing atoms in a fiery ballet, and planets, our cosmic neighbors, are simply vast collections of matter, their surfaces sculpted by the same atomic and molecular laws that shape a dewdrop on a leaf. It's as if the universe, in its immensity, is just a gigantic molecular machine, operating on principles we've only begun to glimpse in our laboratories. Each star, each planet, a complex aggregate of matter, all singing the same molecular song. And there's this persistent, almost poetic tendency in the universe, isn't there? A drive from simplicity towards ever greater complexity. It began, so the story goes, with the most basic of elements, hydrogen and helium, scattered like cosmic dust. But over eons, through the crucible of stars and the slow, patient work of gravity, these simple atoms have coalesced, bonded, and rearranged themselves into ever more intricate structures. From hydrogen clouds to nebulae, from nebulae to stars, from stars to planets, and on some of those planets, to the astonishing bloom of life. It's as if the universe itself is an artist, constantly striving to paint more vibrant, more intricate pictures, moving from a blank canvas to a masterpiece of molecular artistry. This unfolding of complexity also hints at something deeper, something akin to information processing. Think about a biological system, like our own bodies. We're constantly taking in information from our environment, processing it, and responding. Could the universe be doing something similar? Could the laws of physics, the interactions between particles, the very evolution of cosmic structures, be a form of universal information processing? Perhaps the universe isn't just happening, but is actively engaged in a grand computation, a cosmic algorithm unfolding across space-time, shaping itself and its contents. It's a mind-boggling idea that the universe might be a vast, interconnected network, a cosmic computer dreaming in data. And this leads us, gently, to the whispers of panpsychism, the idea that consciousness, or at least a fundamental proto-consciousness, might not be an emergent property of complex brains, but rather a fundamental property of matter itself. What if the very building blocks of the universe, the quarks, the electrons, the atoms, possess a rudimentary form of awareness? Imagine the universe as a vast, interconnected web of these tiny sparks of awareness, each contributing to a larger, cosmic consciousness. It's a beautiful, almost mystical thought that the universe itself might be alive, not just in its grand, visible movements, but in the quiet hum of its fundamental constituents. The universe isn't just a collection of dust and gas, is it? It's a colossal, evolving molecular sculpture, constantly rearranging itself, dreaming new forms into existence. It's a symphony played on the strings of atomic bonds, a cosmic ballad of matter and energy. And this very idea, this notion of a dreaming universe, brings us to the very edge of our understanding. What if the quiet universe, the silent void between the stars, is actually alive with subtle, unseen currents of awareness? So tonight, as you look up at the night sky, or even just imagine it, take a moment. Each star you see, each distant glimmer, is a vast molecular furnace, a tiny part of this grand cosmic unfolding. Consider that each point of light is a testament to the universe's relentless drive towards complexity, its silent processing of information, its potential for a consciousness far grander than our own. But what if the dreaming isn't just about internal organization, but about a connection that defies distance and separation? What if, in the quiet hum of the universe, there are whispers that travel not through space, but through it, carrying secrets between the most unlikely of partners? We're venturing now into a concept that sounds like pure magic, but is in fact a cornerstone of quantum physics, quantum entanglement. Imagine two particles, born from the same cosmic breath, forever bound. They're like two souls who've shared a profound experience, and from that moment on, they carry an echo of each other. This isn't just a similarity, it's a deep, intrinsic link. Their fates are intertwined, no matter how vast the cosmos might stretch between them. If one particle is spinning clockwise, its entangled twin, light years away, will instantaneously be spinning counterclockwise. It's a shared destiny, a silent agreement written into the very fabric of their existence. This brings us to the utterly mind-bending idea of non-locality. In our everyday world, if you want to tell someone something, you have to send a message. It takes time. Light has to travel. But with entangled particles, it's as if distance simply ceases to exist. When we observe or measure one of these particles, its state is determined. And in that very instant, the state of its entangled partner is also determined. It's like a cosmic game of peek-a-boo, where revealing one side of the coin instantly shows you the other, even if that other side is on the other side of the galaxy. This instantaneous influence, this seemingly magical connection across space, is what Einstein famously called spooky action at a distance. It challenges our very understanding of cause and effect, and how information might flow through the universe. Now, this leads to a fascinating debate. Can we actually use this entanglement for communication? Could we send messages faster than the speed of light? The current understanding is a little more nuanced. While the states are correlated instantaneously, you can't choose what state your particle will be in to encode a message. It's like having two perfectly synchronized clocks that always show the same time, but you can't set the time on one to tell the other what to do. So, direct faster than light communication remains elusive. However, the very existence of this entanglement hints at a universe that is far more connected than we often perceive. It suggests that perhaps the universe isn't just a collection of separate things, but rather a vast, interconnected web, a single, shimmering tapestry. And this is where the idea of entanglement as of universal fabric truly begins to resonate. What if this isn't just a peculiar property of a few exotic particles, but a fundamental characteristic of the quantum vacuum itself? Imagine the space between everything, not as empty void, but as a dynamic pulsating field, alive with these invisible connections. Entanglement could be the very threads that weave the universe together, holding it in a coherent, unified state. It's the silent hum beneath all existence, the unseen architecture that allows for the emergence of everything we see and experience. It's the cosmic glue, the foundational resonance that binds the fundamental particles into atoms, atoms into molecules, and molecules into the grand, breathtaking symphony of reality. Think of it this way: entangled particles are like two halves of a single, cosmic coin. You can toss one, and you instantly know the state of the other, no matter how far apart they are. Flip one, and you instantly know the state of the other, no matter how far apart they are. It's a shared reality, a mutual understanding that transcends physical separation. If the universe is so deeply interconnected through entanglement, what does this imply about the nature of our own individual dreams and consciousness? And so, we find ourselves at a most peculiar crossroads, a place where the very act of looking seems to shape what we see. It's as if the universe, in its vast, silent expanse, holds its breath when we draw near, waiting for our gaze to give it form. Could our consciousness, our quiet awareness, be more than just a witness? Could it be an active participant, a gentle hand guiding the universe's grand, unfolding dream? Consider the dance of the wave-particle duality. At the quantum level, these tiny building blocks of everything, they don't seem to settle on a single identity. They exist as a shimmering wave of possibilities, spread out like mist across a meadow. But the moment we try to measure them, to pin them down with an observation, they instantly collapse. They choose a definite state, a single point in space, like a startled deer freezing in the beam of a flashlight. It's as if they were a whisper of potential, and our attention made them into a spoken word. This act of the measurement, it's not some passive peeking. It's an interaction, a forceful nudge. When we set up an experiment to detect a particle, say to see if it's here or there, that very act forces the quantum system into a specific outcome. It's like asking a cloud whether it wants to be rain or mist. The question itself compels a decision. The universe, at its most fundamental level, seems to respond to our curiosity, to our need to know. Now, the thinkers, the quantum philosophers, they've wrestled with this for decades. There's the Copenhagen interpretation, which suggests that the wave function, that spread of possibilities, only becomes real when it's observed. Then there are other, more expansive ideas, like the many worlds interpretation, where every observation causes the universe to branch, creating countless parallel realities, each representing a different outcome. It's a dizzying thought, isn't it, that our act of looking might not just reveal one reality, but create them. And here's where it gets truly provocative, where the whispers of our own consciousness begin to echo in the grand cosmic hall. What if consciousness itself is the ultimate observer, the final arbiter of reality's form? What if our awareness, our subjective experience, is precisely what causes these quantum waves of potential to collapse into the solid, tangible world we perceive? It's a radical notion that our inner landscape might be the loom upon which the outer universe is woven. Imagine, if you will, the universe as a vast, shy creature. It drifts through the cosmos, a symphony of unspoken possibilities, of dream of what could be. But it's a shy creature, you see. It only truly takes definite form, its edges sharpening, its colors deepening, when it knows it's being watched. Our gaze, our conscious attention, is what brings its magnificent dream into focus, transforming the ethereal into the tangible. This brings us to a gentle question, a lingering curiosity. If our observation is so potent, so capable of solidifying reality, what then of the quiet, unobserved corners of existence? The vast stretches of space between galaxies, the silent moments before a thought crystallizes. Are they dreaming in a different way, a more fluid, less defined manner? Are they simply waiting for our attention to ripple through them? Now I invite you, just for a moment, to take a breath. Find something simple, something close by, perhaps the grain of wood on your desk, the subtle texture of your sleeve, or the way light falls on a nearby object. Just observe it. Don't analyze, don't judge. Just be present with it. Notice any subtle shifts in your perception, any deepening of awareness that occurs as you focus your gentle, conscious gaze. What do you feel? What do you see? And so, as we've gently explored the quiet hum of existence, we arrive at a question that whispers from the very fabric of reality itself. It's a notion that suggests our universe, this vast, swirling expanse of stardust and possibility, might be delicately balanced. Imagine, if you will, the fundamental constants of our universe. These aren't just numbers. They are the very rules of the cosmic game, the silent architects of everything we know, from the smallest tremor of an electron to the majestic sweep of galaxies. They seem exquisitely poised, almost as if they were as intentionally set for the blossoming of complex molecules, for the quiet unfurling of life itself. But what exactly are these fundamental constants? Think of them as the universe's essential ingredients, the unchangeable values that define its behavior. We have the gravitational constant, for instance, which dictates the strength of attraction between any two objects with mass. Then there's the speed of light, a cosmic speed limit that shapes our perception of space and time. We also have Planck's constant, a tiny but crucial number that governs the quantum realm, the world of the incredibly small. These are just a few of the bedrock values that form the bedrock of our reality. They are the vast invisible scaffolding upon which everything is built, the silent laws that orchestrate the dance of matter and energy. Now, here's where the wonder deepens, where we encounter what scientists call the fine-tuning problem. It's this peculiar observation that if you were to tweak even one of these fundamental constants, even by the tiniest, almost imperceptible fraction, the universe as we know it would simply cease to be hospitable. Imagine the gravitational constant being just a little bit stronger. Stars would burn out too quickly, leaving no time for planets to form or life to evolve. Make it a little weaker and stars might not ignite at all. If the electromagnetic force were slightly different, atoms wouldn't hold together, and chemistry, the very language of life, would be impossible. It's as if the universe is a masterpiece of delicate calibration, where even the slightest deviation from its precise settings would render its grand symphony unplayable. This leads us to some fascinating philosophical avenues, particularly the anthropic principle. It comes in a few flavors, but at its heart, it tries to explain why the universe seems so perfectly suited for us. The weak anthropic principle suggests that we observe the universe to be this way simply because if it weren't, we wouldn't be here to observe it. It's a bit like saying you only find the perfect cup of tea if you're actually there to drink it. Then there's the strong anthropic principle, which is a little more daring. It posits that the universe must have properties that allow life to develop within it at some stage. It's as if the universe has an inherent tendency towards complexity, a gravitational pull towards consciousness itself. And this precision, this exquisite tuning, naturally leads us to ponder the implications. Does it suggest deliberate cosmic intention, a grand design woven into the very fabric of space-time? Or is it perhaps something more akin to a dream, a deeply inherent organizing principle that manifests as order? It's like finding a perfectly tuned musical instrument, its strings resonating with an almost impossible clarity. The universe, in this light, is not just a random collection of particles, but perhaps a cosmic symphony, meticulously crafted. Its tuning is so precise, so delicate, that even a tiny deviation would render its song unlistenable, its melody lost to an unformed silence. And if the universe is so perfectly tuned, so exquisitely balanced, are the dreaming molecules we've been exploring, the very building blocks of consciousness, also part of a grand, orchestrated cosmic symphony? It makes you wonder, doesn't it? It's a thought that settles softly, like stardust on a quiet evening. Feel the rhythm of your own heartbeat right now. Listen to its steady, precise oscillation. It's a microcosm of this cosmic order, a tiny, personal symphony playing out within you. And in that rhythm, perhaps we can sense a deeper connection, a resonance with the grand, finely tuned orchestra of existence. The universe, as we've begun to understand, isn't quite as still and silent as it might appear. We've been tracing the subtle whispers of activity at the quantum level, and what we're discovering is that even the deepest, darkest, most seemingly empty spaces are, in fact, a vibrant, energetic ocean. It's a place of constant subtle churning, a cosmic broth where the very fabric of existence is brewed. Let's dive a little deeper into this paradoxical emptiness, into what scientists call the quantum vacuum. It's a concept that challenges our everyday intuition, suggesting that nothingness itself is a profound and active participant in reality. One of the most fascinating ideas is zero-point energy. Imagine the coldest, most desolate place imaginable, a place so frigid that all motion, all vibration ceases. Even there, at absolute zero, the quantum vacuum isn't truly still. It possesses a minimum, irreducible amount of energy. It's like a perfectly still pond that, if you look closely enough, would still have infinitesimally small ripples, a fundamental hum of being that can't be silenced. This isn't energy that can be easily harnessed or depleted. It's an intrinsic property of space itself, a baseline vibration that underlies everything. It's the universe's quiet, persistent sigh, and we have experimental evidence for this energetic vacuum, a rather elegant demonstration known as the Casimir effect. Imagine taking two incredibly smooth, uncharged metal plates and bringing them very, very close together in a vacuum. Intuitively, you might think nothing should happen. But what we observe is that these plates are gently, yet undeniably, attracted to each other. This attraction arises because the vacuum between the plates is subtly different from the vacuum outside. The fluctuations of energy, the constant popping in and out of existence of the virtual particles, are slightly restricted between the plates. This restriction creates a pressure difference, a gentle push from the outside vacuum that forces the plates together. It's a tangible whisper from the void, a confirmation that this energetic sea is real and has measurable consequences. These are virtual particles, these fleeting apparitions that flicker in and out of existence in the quantum vacuum, are crucial to understanding this energetic substrate. Think of them as the momentary ripples on that cosmic ocean, the briefest of manifestations from the underlying potential. They aren't particles in the way we typically imagine them, like tiny billiard balls. Instead, they are excitations of quantum fields, like a momentary shimmer on the surface of water. The vacuum isn't just empty space, it's a sea of these potentials, a constant flux of possibility where particles can spontaneously arise and then vanish back into the fundamental energetic substrate. It's a dynamic, ever-present dance of creation and annihilation at the most fundamental level. And this is where things get truly profound. This energetic vacuum, this sea of potential, is increasingly seen as the very source of reality. It's not just a backdrop against which particles play, it's the fertile ground from which all particles and forces emerge. Imagine a vast, silent, energetic ocean. From this ocean, through the subtle dynamics of quantum fields, all the particles we know, the electrons, the quarks, the photons, are born. All the forces that bind the universe together, like gravity and electromagnetism, are also understood as excitations of these fundamental fields, originating from this same energetic substrate. It's as if the entire universe, in all its intricate complexity, is a dream dreamt by this fundamental vacuum. Think of the quantum vacuum like the silent, fertile soil beneath a vibrant garden. It's not empty at all, is it? It's teeming with dormant seeds, with the potential for every bloom, every leaf, every root. It's a reservoir of life, waiting for the right conditions to manifest. That's the vacuum, a fundamental substrate of pure potential, a cosmic womb from which everything arises. And if this vacuum is so profoundly energetic, so filled with the potential for manifestation, could it be the source of the dreaming itself? Could this fundamental energetic substrate be a form of universal consciousness, a vast, silent awareness waiting eternally to manifest? So, as you listen to this, I invite you to do something simple. Breathe in deeply. Feel the vastness of the space around you and the subtle, almost imperceptible energy that permeates it. Feel the stillness and the profound, hidden activity within that stillness. Hello again, dear friends, and welcome back to our quiet exploration. We've been tracing the subtle whispers of consciousness, and tonight, we find ourselves contemplating something truly profound, the arrow of time, and how it relates to those tiny busy workers, the molecules. You see, when we delve into the fundamental laws of physics, It's a bit like looking at a perfectly balanced mobile. Many of these laws at their deepest level seem to be as time symmetric. They don't inherently care if a process is playing forward or backward. A billiard ball collision, for instance, looks pretty much the same whether you watch it in real time or rewind it. Yet, our universe, our lived experience, is undeniably a one-way street. We remember yesterday but not tomorrow. So, how do these infinitesimally small building blocks, these molecules, seem to remember the past, to guide us along this relentless forward march? It all begins with a grand, sweeping principle, thermodynamics, and its second law. This law, in essence, tells us that in any closed system, disorder tends to increase. Think of a perfectly organized deck of cards. If you shuffle it even just a little, it becomes less ordered. Shuffle it again, and it becomes even more so. Eventually, it reaches a state of maximum randomness, where any further shuffling won't make it a more disordered. This inevitable slide towards disorder is what physicists call entropy. It's the universe's gentle, persistent tendency to spread things out, to smooth out the bumps, to move from the neatly arranged to the delightfully messy. Now, this increase in disorder, this entropy, is what gives us the macroscopic arrow of time. While an individual molecule might jiggle this way and that, seemingly at random, when you have a vast, unimaginable number of them, like in a cup of coffee, or the air you breathe, their collective behavior becomes predictable. It's like a massive crowd. While one person might spontaneously decide to walk backward, the overwhelming majority will move forward, creating a discernible flow. The statistical behavior of these countless molecules, their tendency to move towards states of greater probability, which are also states of greater disorder, creates that undeniable sense of directionality. It's the universe sighing and settling into a more comfortable, spread-out state. And this is where the fascinating idea of information encoding in molecules comes into play. Think about how a DNA molecule carries the blueprint for a living organism. Its specific sequence, the precise arrangement of its atoms, is a form of stored information. This isn't just random jiggling, it's a carefully constructed pattern. Chemical reactions, the way molecules bond and break apart, the very structures they form, all of these are influenced by their past interactions. A molecule that has been heated will have a different energy state than one that has been cooled. A molecule that has participated in a specific reaction carries a subtle imprint of that event. This is a form of molecular memory, a subtle but real record of what has happened. Ultimately, connecting this back to the arrow of time, we can think of the past as simply a state of lower entropy. The universe began in a state of incredibly low entropy, a highly ordered, concentrated beginning. As time progresses, it moves towards states of higher entropy, greater disorder, and more spread out energy. So, when we talk about molecules remembering the past, it's because their current state is a consequence of their journey through these increasing entropy levels. They are, in a sense, carrying the echoes of their less disordered past. It's a bit like watching a mighty river flow. While individual water molecules can swirl and eddy, even momentarily moving upstream in a tiny eddy, the river as a whole, the grand procession of water, is inevitably and powerfully drawn downhill, towards the vast, boundless sea. That downhill pull, that unstoppable movement, is the arrow of time, etched into the very fabric of existence. And if molecules, in their own silent way, hold a form of memory, a record of their journey, it makes one wonder, could the universe itself be dreaming its own history, replaying patterns of organization and reorganization, a vast, cosmic memory unfolding? Here, in your hand, I invite you to hold a smooth stone. Feel its weight, its cool solidity. Trace the subtle contours, perhaps a slight ripple or a smoothed-out edge. This stone, a testament to billions of years of molecular persistence, carries within its very form a silent narrative. It remembers the heat of its formation, the slow erosion by wind and water, the pressure of the earth. It's a tangible whisper of time's enduring passage, a reminder that even the seemingly unchanging holds a profound history within its molecular heart. The universe's molecular dance isn't confined to the vast, silent stretches of the cosmos. It's intimately woven into the very fabric of life itself, right here, within us. It turns out, those strange, beautiful rules of the quantum world aren't just for distant stars and subatomic particles. They're humming softly, orchestrating the most fundamental processes of living beings. Take, for instance, the quiet miracle of photosynthesis. Plants, these patient green artists, are masters of capturing sunlight. And how do they do it so incredibly well, with such astonishing efficiency? It's not just a simple absorption of light. It seems they're using a quantum coherence. Imagine a tiny wave of light energy, like a shimmering dewdrop, arriving at a leaf. Instead of just bouncing around randomly, this energy wave, in a quantum sense, explores all possible paths through the complex network of molecules within the plant's light, harvesting complexes simultaneously. It's like a single thought that can consider 1,000 different ideas all at once, finding the most direct route to where it needs to go, minimizing energy loss. This quantum shortcut allows plants to harvest light with near perfect efficiency, a feat that would be utterly impossible if it were just following classical, step-by-step rules. It's a molecular dance of pure, unadulterated elegance. And then there are enzymes. These are the tireless molecular workers within our cells, the tiny chemists that make almost every biological reaction possible. They speed up processes that would otherwise take eons, like turning a slow trickle into a rushing river. But some enzymes perform their tasks with a speed that baffles classical physics. They achieve this through a phenomenon called quantum tunneling. Imagine trying to push a ball over a hill. Classically, you need enough energy to get it to the top. But in the quantum realm, there's a tiny, yet significant, chance that the ball can simply appear on the other side of the hill without ever having enough energy to climb it. Enzymes leverage this. Their reactant molecules, instead of needing to overcome an energy barrier, can tunnel right through it, allowing reactions to happen in a fraction of the time. It's like a secret passage that bypasses the expected journey, a molecular sleight of hand that keeps life's machinery running smoothly. Even something as seemingly mundane as bird migration might be touched by quantum magic. How do these feathered navigators find their way across vast continents, often with pinpoint accuracy, even on cloudy days when the sun isn't visible? Scientists are exploring the idea that they possess a magnetic sense, and that this sense is rooted in this quantum entanglement. Imagine two particles, like two tiny spinning coins, that are so deeply linked that no matter how far apart they are, if one lands heads, the other instantly lands tails. In the eyes of a migrating bird, certain molecules in their retinas might become entangled. When exposed to the Earth's magnetic field, these entangled molecules could subtly change their properties, and this change, amplified by the quantum connection, could be perceived by the bird as a directional compass. It's a biological compass guided by the invisible threads of entanglement, a truly mind-boggling prospect. So, what does this all mean? It suggests that the life itself might be inherently quantum. These aren't just isolated, quirky phenomena, they might be fundamental requirements for biological processes to occur at all. Life, in its most basic form, could be a sophisticated manifestation of quantum mechanics, a grand experiment where molecules are orchestrated to perform feats of impossible efficiency and profound connection, all happening within the quiet hum of existence. Life itself is a sophisticated quantum experiment where molecules are orchestrated to perform feats of impossible efficiency and connection. It's as if the universe, in its infinite creativity, decided to take its most fundamental, mind-bending rules and apply them to the building blocks of life, creating wonders we are only just beginning to glimpse. If life harnesses quantum mechanics in these intricate ways, are our own dreams, our thoughts, our very consciousness, also subtle expressions of these fundamental, subtle quantum energies? Are we, in essence, biological quantum computers dreaming in a quiet universe? Hello there, dear wanderers. Welcome back to Conscious Frequency. We've been exploring the quiet hum of the universe, the whispers of dreaming molecules, and tonight, we'll gently touch upon a concept that helps us understand how this symphony of existence truly comes to be: the philosophy of emergency. It's the idea that sometimes, the whole is so much more than just the sum of its parts. So, what exactly is emergence? Think of it this way: it's when a collection of simple things, interacting in specific ways, suddenly give rise to something entirely new, something that wasn't present in any of the individual pieces. It's like a secret ingredient that only appears when everything else is in the pot, stirred just so. This is quite different from simple additive properties. If you have 2 bricks, you have the weight of 2 bricks. That's additive. But with emergence, it's not about adding up properties, it's about as qualitatively new properties arising from the as relationships between those parts. It's the difference between counting apples and tasting apple pie. We see this beautiful dance of emergence all around us, woven into the very fabric of nature. Take water, for instance. A single hydrogen atom isn't wet. An oxygen atom isn't wet. But when 2 hydrogen atoms bond with an oxygen atom forming H2O, something truly magical happens. Wetness emerges. Or consider the breathtaking spectacle of a flock of starlings, a murmuration. Each bird is just a bird, flying. But together, through simple rules of proximity and alignment, they create these fluid, impossibly intricate aerial ballots. And then there's consciousness itself, perhaps the most profound emergent property we know, arising from the intricate, electrochemical dance of billions of neurons in our brains. This brings us back, gently, to that age-old puzzle, the mind-body problem. How does this rich, subjective experience of being, our thoughts, our feelings, our awareness emerge from the seemingly unfeeling, purely physical stuff of the brain? It's not that the brain contains consciousness like a hidden gem. Rather, consciousness emerges from the incredibly complex and dynamic interactions of the brain's components. The intricate web of neural connections, the firing of synapses, the flow of neurotransmitters, these are the individual notes. But the symphony of consciousness is something entirely new, something that arises from their collective, dynamic performance. And this leads us to a perhaps even grander, more speculative question. Could the universe itself possess emergent properties beyond our current grasp? Could there be a kind of cosmic consciousness, a universal awareness, that emerges from the vast, interconnected web of galaxies, stars, and energy? It's a thought that tickles the edges of our understanding, a whisper that perhaps the universe isn't just a collection of inert matter, but a vast unfolding dream with its own form of emergent awareness, a cosmic mind dreaming itself into existence. Think of it like this: a single brushstroke, on its own, is just pigment on canvas. It holds no story, no emotion. But when millions of these simple brushstrokes are placed with intention, with care, interacting with light and shadow, they can coalesce into a breathtaking portrait. A portrait that evokes feeling, that tells a story, that possesses a beauty, and asks meaning far beyond any individual stroke. It's a conscious creation, born from the emergent properties of the whole. And if this principle of emergence is truly as fundamental as it seems, then perhaps our idea of molecules, dreaming, isn't just a poetic metaphor. Perhaps it's a literal description, a way of understanding how reality, in all its astonishing complexity and beauty, unfolds from the simplest of interactions, a cosmic dream weaving itself into being. As you move through your day, perhaps you can feel this sense of emergence in your own life. Consider a complex system you are a part of: your family, your community, even the intricate workings of your own body. Notice how collective behaviors, shared feelings, and unique dynamics emerge from the interactions of the individuals within them. It's a subtle, beautiful reminder of the profound interconnectedness that shapes our world. So, if we're starting to feel that the universe itself might be evolving, might be as a remembering its past states, then a truly fascinating question arises. How might this cosmic memory, this grand narrative of existence, be encoded, not just in abstract concepts, but in the very molecular fabric of everything we see and touch? It's like asking if the universe has a kind of molecular autobiography, written in the language of atoms and energy. Let's begin with the most ancient echo we can perceive, the cosmic microwave background, or CMB. Imagine, if you will, stepping back through time, not by years but by billions of years, to a moment when the cosmos was just a fraction of its current age. The CMB is like the fossil radiation from that incredibly early universe. It's a snapshot, a cosmic baby photo, capturing the universe at its infancy, when it was a swirling, incandescent soup of fundamental particles and energy. This radiation, still gently bathing us, carries within it the imprints of the initial molecular and energetic state of everything. It's a whisper from the very beginning, telling us what the universe was made of, how it was distributed, and the fundamental forces at play, all encoded in the subtle variations of its temperature and polarization. It's the universe's first incredibly faint memory. Then, consider the grand cosmic forges the stars. Stellar nucleosynthesis, the process by which stars create heavier elements from lighter ones, is essentially cosmic history being rewritten in atomic form. When a star like our Sun fuses hydrogen into helium, it's not just creating light and heat, it's also building the very atoms that will eventually become part of us, part of planets, part of everything. The carbon in your body, the iron in your blood, the calcium in your bones, all of these were forged in the fiery hearts of stars that lived and died long before our solar system even existed. Each heavier element carries, within it the EV imprint of the conditions under which it was formed, a molecular testament to the universe's past, to the supernova that seeded the cosmos with the building blocks of life. It's a lineage, written in the very elements that comprise us. Now we venture into the enigmatic depths of black holes, and here we encounter the intriguing information paradox. When matter, with all its intricate molecular arrangements and energetic states, falls into a black hole, what happens to that information? Does it simply vanish, erased from the cosmic ledger? Or is it somehow preserved, perhaps encoded on the event horizon, the black hole's boundary? This paradox touches upon the very idea of cosmic memory. If information, the fundamental description of a system, can be truly lost, then the universe's memory would have gaps, lost pages. But many physicists believe that information is never truly lost, suggesting that even within these seemingly all-consuming voids, there's a subtle, perhaps incomprehensible, form of cosmic remembrance. This leads us to the profound concept of the holographic principle. Imagine, if you will, that the three-dimensional universe we experience might be a kind of projection, a holographic image, of information encoded on a distant, two-dimensional boundary. This idea suggests that all the information about a volume of space, including all its molecular configurations and histories, could be stored on its surface. It's a mind-bending thought, implying that the universe's memory isn't just scattered throughout its vastness, but might be universally accessible, like a cosmic database accessible from its edges. Every point in space might, in a sense, hold a condensed version of the universe's entire informational history. It's like thinking of the universe as an ancient, sprawling library. Each star, each atom, each particle of dust, is like a single page, holding within its molecular structure a testament to its journey, a whisper of the cosmic events it has witnessed. From the faint glow of the CMB to the heavy elements forged in stellar furnaces, and even the mysteries held within black holes, the universe seems to be weaving a continuous narrative, a molecular testament to its incredible journey. And if the universe remembers, if it carries these echoes of its past within its very molecular makeup, then it begs another, even more whimsical question. Is it also dreaming of future states, guided by the deep, resonant patterns of its past? So, as you gaze up at the night sky, or simply feel the ground beneath your feet, try to imagine this vast, silent archive. What whispers of the past do you feel resonating within it, within you? Hello there, gentle souls. Welcome back to Conscious Frequency, where we explore the mysteries of consciousness through the soft lens of scientific wonder. Tonight, we drift into a truly fascinating corner of quantum mechanics, a place where observation itself seems to hold a kind of power, a power to not just reveal, but perhaps to freeze a moment. We're talking about the quantum Zeno effect, and its rather poetic implications for what we might call frozen dreams. So, let's unpack this. At its heart, the quantum Zeno effect is this rather peculiar idea. If you keep measuring a quantum system over and over again, very, very frequently, you can actually prevent it from changing its state. Imagine a quantum system as a tiny, restless spirit, poised on the brink of transformation, like a dewdrop about to fall from a leaf. If you're constantly peaking, constantly asking, "Are you still there? Are you still in this state?" you're essentially interrupting its natural dance, its inherent tendency to evolve. It's like asking a seed, "Are you growing yet?" every single second. That constant, intrusive attention can, in a way, keep it stuck in its seed, like potential, preventing the unfolding of its destiny. The act of observation in this context becomes a kind of temporal anchor. Now, let's stretch this idea just a little and think about a molecule. Molecules are constantly in motion, vibrating, interacting, exploring their potential energy states. You could almost imagine a molecule, in a very abstract sense, dreaming of a different configuration, a different dance. If we were to apply the logic of the Zeno effect to this dreaming molecule, if we were to continuously, relentlessly observe its current state, its precise position and momentum, would its potential dream, its unmanifested configuration, remain perpetually unfulfilled? Is its potential future, its quantum possibility, held captive by our unwavering gaze? Like a shy creature frozen in the spotlight? It's a thought that makes you wonder about the subtle influence of our attention, doesn't it? And this leads us to ponder the role of our own consciousness, our focused attention, in what we perceive as our reality. If the act of observing can, in essence, freeze a quantum system, could our continuous, focused attention be contributing to the very stability of the reality we experience? Think about it. When we are deeply engrossed in something, when our attention is laser-focused, the world around us can seem to fade, to become less dynamic, almost solidified by our awareness. It's as if our consciousness, by choosing to observe and engage with a particular aspect of existence, helps to anchor it, to give it that sense of permanence that we associate with the tangible world. Our attention, in this sense, might be a gentle, yet powerful sculptor of our experienced universe. This brings us to a delicate dance, a beautiful interplay between observation and evolution. The universe, at its most fundamental level, is a realm of constant flux, of probabilities shifting and evolving. Yet our consciousness, through its very nature of observing, of engaging, can introduce a form of stability. It's like the universe is a vast, unwritten symphony, full of potential melodies, and our consciousness is the conductor, choosing which notes to highlight, which movements to bring to the forefront. There's a profound balance here: the universe's inherent tendency to explore its infinite possibilities, its quantum dreams, and our conscious capacity to bring focus, to give form, to stabilize certain aspects of that unfolding potential. It's a cosmic conversation, really. Imagine for a moment a butterfly in mid-flight. Picture its wings, a blur of iridescent color, catching the sunlight as it navigates the air with effortless grace. Now, imagine you had a camera that could capture its exact position, its exact wing angle, at an incredibly rapid pace. If you were to continuously photograph it frame after frame, freezing each infinitesimal moment of its journey, you might inadvertently keep it suspended in that perpetual instant, its natural, fluid flight path interrupted. It's as if your persistent observation, your desire to capture every detail, has unintentionally halted its natural progression, its freedom to simply be in motion. And this leads us to a profound curiosity, doesn't it? If observation, our focused attention, can indeed freeze a dream, can hold a quantum system in a state of suspended animation, what happens in the vast, unobserved stretches of the quiet universe? Are its dreams, its infinite possibilities, constantly unfolding in a glorious, unhindered ballad of creation, or are they, too, frozen in an eternal, silent moment, waiting for a consciousness to perhaps, just perhaps, notice them? Let's take a moment right now, just for a few breaths. Bring your awareness gently to your own breath. Feel the subtle rhythm, the inhale, the exhale. Notice the gentle stability that this focused, quiet attention can bring. Just breathe. And so, we find ourselves at a precipice, a place where the very fabric of existence seems to hum with a singular, cosmic song. Some of the most profound theories in quantum physics whisper of a concept so grand, so encompassing, that it makes our individual thoughts feel like mere ripples on an infinite ocean. They propose a single, overarching wave function for the entire universe. Imagine that for a moment. Not just the wave function of an electron or a photon, but the wave function of everything. Could this be the ultimate, dreaming molecule? A singular quantum state that describes all of reality, from the smallest quark to the most distant galaxy, and yes, even our own awareness. It's a thought that feels both incredibly vast and surprisingly intimate, doesn't it? Let's dive into this idea of the wave function of the universe. In quantum mechanics, a wave function is essentially a mathematical description of a quantum system. It tells us the probability of finding a particle in a certain state, or at a certain place. Now, extrapolate that to the entire cosmos. This universal wave function would, in theory, contain the quantum state of every single particle, every field, every interaction that has ever occurred or ever will occur. It's a blueprint, a cosmic probability cloud, encompassing all possibilities within its vast, ethereal embrace. Think of it as the ultimate probability map, charting the potential of all that is, was, and could be. It's the universe in its most fundamental, probabilistic form, before any specific outcome is observed or measured. And within this grand universal wave function, the concept of the many worlds interpretation finds its most fertile ground. If the universe is indeed described by a single, evolving wave function, then every time a quantum measurement or interaction occurs, and these happen incessantly, everywhere, all the time, that wave function doesn't just collapse into one outcome. Instead, according to this interpretation, it branches. Each possible outcome becomes a reality in its own separate, parallel universe. So this single universal wave function could be the progenitor of countless, branching realities, a cosmic tree with an infinite number of limbs, each representing a different unfolding of events. We're living in one branch, but countless others are also playing out simultaneously, each a unique permutation of the universal potential. This leads us to a truly mind-bending idea that information might be the very basis of reality. If the universe is fundamentally described by this universal wave function, then perhaps the universe is information. It's a colossal, interconnected network of data, a quantum computation unfolding across spacetime. This wave function isn't just a description. It is the underlying reality, the fundamental language of existence. Everything we perceive, the solidity of matter, the warmth of the sun, the very thoughts flickering through our minds, could be emergent properties, expressions of this ultimate quantum information. It's like the universe is a vast, intricate algorithm, constantly processing and generating its own reality. And if we consider this universal wave function as the fundamental essence of existence, then perhaps the dream itself is simply a manifestation of this wave function's evolution. If the universe is a single, quantum entity, its continuous unfolding, its inherent potential, its journey through time and space, all of it could be seen as its collective, cosmic dream. Our individual dreams, those fleeting, often bizarre narratives we experience in sleep, might be tiny echoes, localized manifestations of this larger, universal dreaming process. It's the universe dreaming itself into existence, moment by moment, possibility by possibility. Think of the universe's wave function as an infinitely complex cosmic score. Each moment, each particle, each conscious thought is a unique note played from this universal symphony, a melody arising from the fundamental potential encoded within that score. If we are all part of this single, dreaming wave function, what does that mean for our individual consciousness and our connection to the cosmos? It's a question that invites a deep sense of wonder, doesn't it? It suggests that perhaps we're not separate observers looking out at the universe, but rather integral parts of its grand unfolding dream. And so we find ourselves here in this vast, quiet expanse. It's easy to imagine it as empty, as a silent, dark canvas. But what if this quiet universe, far from being inert, is actually saturated with potential? It's like a deep, hushed breath held before a symphony begins. What is this potential, this invisible hum? And how does it connect to our own peculiar, dreaming molecules? Let's start with something familiar, something we see in the world around us. In physics, we talk about potential energy. Think of a ball perched precariously on the edge of a hill. It's not moving. It's not doing anything outwardly, but it holds within it this capacity to roll, to gain speed, to do work. It's energy waiting. It's the promise of movement, the latent power to cause a change, a cascade of events. It's the universe's way of saying, I've got this stored up, just in case. It's the coiled spring, the drawn bowstring, the silent anticipation of action. Now, let's gently dip our toes into the even stranger waters of quantum mechanics. Here, potential takes on a truly ethereal form. Particles, the very building blocks of everything we perceive, don't always exist as solid, definite things. Instead, they often exist in a state of quantum potentiality. Imagine a cloud of pure probability, a shimmer of might be. A particle like an electron can be in multiple places at once, or have multiple properties, all at the same time, until we observe it. The act of looking, of measuring, forces it to choose a definite state. It's as if the universe whispers possibilities, and only when we lean in to listen does one particular whisper become a tangible reality. It's a universe that's always considering, always holding a spectrum of options. This leads us to a grander thought: the universe itself is brimming with latent possibilities. Think about it. The universe could have unfolded in an infinite number of ways. The fundamental constants, the very laws that govern existence, could have been slightly different. And even now, at this very moment, there are countless pathways the cosmos could take. It's a tapestry woven with threads of what A is, but also with the shimmering, unspun fibers of what A could be. The future isn't a single, predetermined line, but a vast, branching nebula of potential futures, each waiting for its moment to ignite. It's a cosmic shrug of infinite what-ifs. So, if this is the case, if the universe is a vast ocean of potential, then perhaps this potential is its very dreaming state. Before the stars flared, before galaxies spun into being, there was just potential. A silent, pregnant pause. It's the universe's unmanifested dream, its grand, unwritten story. Our dreaming molecules, the very essence of our consciousness, might be resonating with this fundamental cosmic dream, tapping into that same wellspring of possibility. It's the universe dreaming itself awake, and perhaps, in our own way, we are part of that awakening. Think of a seed. It's small, unassuming, perhaps even overlooked. But within its humble shell lies the immense, breathtaking potential to become a mighty tree. It holds within it the blueprint for a universe of its own, a canopy reaching for the sun, roots delving into the earth, a whole ecosystem thriving within its branches. This seed is a perfect metaphor for potential, a tiny capsule of unfulfilled promise, waiting patiently for the right conditions: the warmth of the sun, the kiss of the rain, the gentle embrace of the soil to unfurl its quiet, magnificent dream. And if potential, this cosmic dream, is indeed the very fabric of our quiet universe, then the question arises, doesn't it? How do we, as conscious beings, as these tiny, intricate sparks of awareness, how do we tap into our own unique potential? And perhaps even more profoundly, how might we, in our own gentle way, influence the universe's unfolding dream? What dreams are waiting, dormant within you, just begging for a whisper of encouragement to awaken? We, as conscious observers, are not separate from this cosmic dream. We are its participants, its interpreters, and perhaps even its co-creators. Think of consciousness as a magnificent, shimmering lens. The universe, in its raw, unadulterated form, is like an ocean of pure energy, a symphony of vibrating frequencies, a blizzard of particles dancing in the void. Without our awareness, this ocean is just potential. This symphony is silent. This blizzard is unseen. Our consciousness acts as this intricate lens, filtering, shaping, and interpreting this raw data. It's like the frosted glass on a window. It doesn't create the light outside, but it certainly colors how we perceive its warmth and its glow. Each of us, with our unique history, our unique senses, our unique inner landscape, is a distinct lens, and the universe, as we experience it, is the light that has passed through that particular, precious piece of glass. And this brings us to the beautiful, bewildering subjectivity of experience. Your dream of the universe, the one you wake up to each morning, is entirely your own. It's woven from the threads of your memories, the scent of your favorite flower, the echo of a loved one's laughter, the sting of a forgotten hurt. The universe, as a grand, silent canvas, provides the pigments, but it's your consciousness that holds the brush. It's a deeply personal, intimate affair, this experiencing of reality. What feels like a vast, open space to one might be a crowded, bustling marketplace to another, all depending on the inner weather of their own unique dream. There's no universal thermostat for awe, no single frequency for wonder that resonates identically for everyone. Now let's gently touch upon that curious puzzle in the quantum world, the Higgs measurement problem. For so long, we've pondered how the act of observing, of measuring, seems to collapse possibilities into a singular reality. But perhaps, from our human perspective, it's less about a cold, scientific intrusion and more about of conscious engagement. Imagine the universe as a vast, unwritten story, a tapestry of potential narratives. When our consciousness, our personal awareness, focuses on a particular thread, a particular possibility, it's like leaning in to read a specific sentence, giving it weight, giving it form within our own narrative. We're not just passive bystanders, we're active participants, lending our own unique attention to the unfolding cosmic dream. And in this vast, often silent expanse, where do we find our as meaning? The universe, in its infinite grandeur, might be utterly indifferent to our existence. Stars explode, galaxies collide, and the cosmic ballet continues its silent, majestic dance oblivious to our fleeting presence. But it is through our conscious experience, through the richness of our awareness, that significance blossoms. We are the universe's way of knowing itself. Our joy, our sorrow, our love, our curiosity, these are the colors that paint the cosmic canvas. Without conscious observers, the universe would simply be a silent, unobserved spectacle. It's our capacity to feel, to wonder, to question, that imbues this grand, indifferent expanse with a sense of purpose, a sense of beauty. We are like tiny sentient sparks within the vast, quiet darkness of the universe. Our awareness illuminates our immediate surroundings, giving form to our personal corner of the cosmic dream. And if we are indeed these active participants, these conscious sparks, what responsibilities, if any, do we hold in shaping the universe's unfolding dream? Take a slow, deliberate breath. Feel the aliveness of your own conscious presence in this moment. Beyond the tangible bonds that hold molecules together, those sturdy, predictable connections we can measure and chart, are there subtler, unseen threads that weave through the very fabric of existence? Are we, in our deepest essence, linked by something far more profound than the simple push and pull of electromagnetism? It's a question that tickles the edges of our understanding, like a forgotten melody just out of reach. Consider for a moment the quantum field. It's not just a theoretical construct, but the very, very ground floor of reality. Think of it as an infinite, shimmering ocean, and every particle we know, the electrons, the quarks, even the light itself, are simply ripples, temporary excitations in this single unified medium. Everything, absolutely everything, arises from this one boundless expanse. It's like realizing that every single dewdrop on a vast meadow is, in its fundamental nature, just a tiny piece of the same immense sky. And then there's entanglement. This is where things get truly peculiar, and wonderfully so. When two particles become entangled, they become intrinsically linked, no matter how far apart they are. Measure one, and instantly, the other reflects that measurement, as if instantaneously communicating across unimaginable distances. It's as if they share a secret handshake, a silent understanding that defies the usual rules of space and time. This suggests a fundamental interconnectedness, a cosmic dance where separation is, in a way, an illusion. Imagine two leaves on opposite sides of the planet, yet somehow when one trembles in the breeze, the other feels a sympathetic shiver. This leads us to some truly speculative, yet fascinating, ideas about consciousness. What if consciousness itself isn't confined to the physical brain, like a radio signal broadcast from a single tower? What if it's a non-local phenomenon, a field that permeates everything, much like the quantum field itself? Perhaps our individual consciousness is more like a localized eddy within this vaster, universal stream. It's a thought that opens up a universe of possibilities, suggesting that the I we perceive might be a beautifully intricate facet of a much larger, conscious whole. And this brings us to the notion of the universe dreaming. If everything is interconnected, if consciousness is a pervasive field, could the very molecules, the fundamental building blocks of existence, be participating in a grand, cosmic dream? Imagine a vast, silent symphony playing out, not with sound, but with subtle energetic shifts, with the ebb and flow of these fundamental excitations. Perhaps what we perceive as our individual realities are simply fleeting, vivid dreams within this single, vast, interconnected consciousness. It's a poetic thought, isn't it? The universe, dreaming itself into being, molecule by molecule. Imagine the universe as an ocean. Molecules are like individual waves, cresting and falling, appearing and disappearing on the surface. But they are all part of the same water, aren't they? They are interconnected by the vast, unseen currents that flow deep and powerful beneath the surface, shaping their movement, their very existence. If these unseen connections are real, if we are all part of this grand, cosmic dream, then how can we learn to perceive them? How can we tune into this universal frequency, to feel the universe's dream more directly, more intimately? Gently place your hand on your heart right now. Feel the steady rhythm, the gentle rise and fall. Can you sense it? That pulse, that quiet beat, is a tiny echo, a whisper of your connection to the vast, unseen network of existence. It's a reminder that even in our perceived solitude, we are woven into the grand tapestry, breathing with the universe. We've been so captivated, haven't we, by the vibrant dance of these dreaming molecules, these tiny, energetic sparks that seem to hum with an inherent awareness. But as we marvel at their intricate ballet, a gentle whisper arises, asking about the stage upon which they perform. What about the profound silence, the czar's absence that frames their every graceful pirouette? It's easy to overlook, isn't it? This vast, seemingly empty canvas. Yet this very vacuum, this apparent nothingness, is the as fundamental bedrock of our quantum reality. Think of it not as a void, but as a fertile ground, teeming with potential energy, a sea of fluctuating fields just waiting for a ripple, a nudge to coalesce into something tangible. It's the ultimate cosmic womb, from which all existence, all matter, all light eventually emerges. Without this omnipresent vacuum, there would be no space for anything to be. And this nothingness is precisely what enables everything. Imagine a world where every inch of space was already packed solid with matter. Where would the electromagnetic force travel? How would gravity ever exert its gentle pull across the cosmos? It's the absence of matter that allows these invisible fields and forces to weave their intricate tapestry, to connect distant stars, to hold atoms together, and to permit the very interactions that bring our dreaming molecules to life. It's like the clear sky that allows the sunlight to stream through, illuminating the world. This concept of silence as potential is truly a captivating one. Just as the vacuum isn't truly empty, but rather a vibrant, fluctuating field, so too is silence not merely the absence of sound. It's a space pregnant with unmanifested potential. Think of a quiet room before the music begins. It's not just empty, it's waiting. It holds the potential for melody, for rhythm, for emotion. It's in that quiet anticipation that the coming notes will find their true meaning and impact. Silence, in this sense, is the fertile soil from which all sound, all expression, can blossom. And when we turn our gaze outward to the grand theater of the universe, we encounter this profound quiet on a scale that can humble us. The vast, silent spaces between celestial bodies, the immense gulfs separating galaxies, are not just empty voids. They are the cosmic quietude, the silent breath of the universe. This immense quiet is where light travels for eons, where gravitational waves ripple unseen, where the very fabric of space-time stretches and bends. It's in this vast, silent expanse that the grand cosmic dream unfolds, a dream woven from both the luminous presence of stars and the deep, resonant quiet that surrounds them. It reminds me, so vividly, of music. Think about a beautiful piece of music. What gives it its soul, its rhythm, its emotional depth? It's not just the notes, is it? It's the silence between the notes. Those brief moments of quiet, of absence, are what define the melody, allowing each note to resonate, to breathe, to have its full impact. Without that silence, the music would be a monotonous drone, a chaotic jumble. The space between the notes is as crucial as the notes themselves. It's what shapes the music, what allows us to feel its joy, its melancholy, its profound beauty. So, if silence and absence are so vital, so fundamental to the very fabric of reality, how do they contribute to the universe's grand, unfolding dream? And as we ponder that, I invite you, just for a moment, to embrace the quiet. Take a moment to simply be still. Let the world around you soften, let the sounds fade, and embrace the quiet that resides both outside and, perhaps more surprisingly, within you. Feel the gentle stillness, the absence of striving, and just be. The universe's molecular dance is not static, it's a continuous cycle of creation, transformation, and dissolution. Think of it for a moment as a cosmic ballet, where every particle, every atom, every molecule is a dancer. And this dance, it's never truly still. It's a perpetual becoming, a gentle unraveling and reweaving. We often speak of life and death as opposites, starkly defined. But when we look closer, at the very building blocks of everything, we see a much softer, more fluid reality. It's a continuous cycle, a grand, molecular symphony playing out across the vastness of space and time. It all begins, in a way, with the magnificent, fiery hearts of stars. Imagine these celestial furnaces born from nebulae of gas and dust, vast clouds of hydrogen and helium. Within their crushing gravity and searing heat, a profound alchemy takes place. Hydrogen atoms, those simplest, lightest dancers, are forced together, fusing into helium. And as they continue to burn, they forge heavier elements: carbon, oxygen, nitrogen, the very atoms that make up you and me, this microphone, the air we breathe. When these stars reach the end of their lives, some explode in spectacular supernova, scattering these newly forged elements like stardust across the cosmos. This stardust, this molecular inheritance, then drifts, waiting for the next gravitational tug, the next spark of fusion, to begin the dance anew. And this cycle, it's not just happening in distant galaxies. It's happening everywhere, all the time. The atoms that make up your body right now have, in their past lives, been part of ancient stars, perhaps even dinosaurs or the very first oceans. When a molecule breaks down, its constituent atoms don't vanish. They're simply freed, ready to join a new molecular formation. Think of it like a vast cosmic recycling program. Water molecules evaporate, become clouds, fall as rain, and are absorbed by plants, which are then eaten by animals, or they might simply flow back into the ocean. Carbon atoms are exchanged between the atmosphere, the earth, and living beings in a constant, intricate flow. It's a perpetual redistribution of the fundamental ingredients of existence. Even within our own bodies, this cycle of creation and dissolution is beautifully orchestrated. We have a process called apoptosis, often called programmed cell death. It's not a violent end, but a gentle, controlled dismantling. Imagine a meticulously organized demolition crew within each cell. Enzymes are activated, carefully breaking down the cell's components, its membranes, its proteins, its DNA, into smaller, reusable pieces. These molecular fragments are then absorbed by neighboring cells, or by specialized scavenger cells, becoming fuel for new growth, for repair, for the continuation of life's intricate tapestry. It's a testament to the universe's elegant efficiency. So, if death, at its most fundamental level, is simply a transformation, a dissolution of one molecular organization to allow for the emergence of another, what does that really mean? It suggests that perhaps life and death aren't such distinct endpoints as we often perceive. They are more like phases in an ongoing cosmic dream. The molecules that once formed a star, then a planet, then a living organism, continue their journey, their essence undiminished, merely changing their form, their dance partners, their stage. It's a continuous unfolding, a perpetual metamorphosis. The universe is like a magnificent, ever-burning bonfire. Old molecules are consumed, their essence returning to the cosmic forge to create new, radiant forms. If death is a part of this molecular dream, what does that tell us about the nature of existence and continuity? Feel the gentle rhythm of your own breath. It's a constant cycle of exchange, of taking in and letting go. And so, as we continue to unfurl the quiet universe's slumber, we find ourselves drawn to a truly fundamental aspect of its grand, unfolding dream. It's a dream woven not from fleeting images, but from an inherent, almost irresistible, tendency towards self-organization. Think about it, from the simplest whisper of atoms coalescing to the breathtaking complexity of life itself. There's this persistent urge towards order, towards structure, like a sculptor coaxing form from formless clay. This remarkable phenomenon, this dance of coming together, is deeply intertwined with the laws of thermodynamics, but perhaps in a way that surprises us. We often associate thermodynamics with decay, with a universe slowly winding down, heading towards a state of maximum entropy, a bland uniformity. But that's the story of closed systems, systems sealed off from the outside world, like a perfectly insulated box. Our universe, however, is decidedly not a closed system. It's an as-open system, constantly exchanging energy and matter with its surroundings. And it's within these far from equilibrium conditions that the magic of spontaneous organization truly begins to bloom. It's like a river, not a stagnant pond. The constant flow of water, the energy it carries, allows for the formation of beautiful, intricate eddies and currents, patterns that wouldn't exist in still water. This idea finds a beautiful, if somewhat abstract, expression in the work of Ilya Prigogine, who spoke of dissipative structures. These are ordered patterns that emerge and are maintained precisely because a system is dissipating energy. Imagine a flame, for instance. It's a highly ordered structure, a vibrant dance of molecules. But it only exists as long as it's actively consuming fuel and releasing heat and light. It's dissipating energy. These structures are not static, they are dynamic, constantly being built and rebuilt by the flow of energy through them. They are like living sculptures, sculpted by the very act of energetic exchange, a testament to how chaos, when channeled correctly, can give birth to exquisite order. And then, the ultimate expression of this cosmic drive, the very quest that keeps scientists awake at night, is the origin of life. How did non-living molecules, the simple building blocks scattered across the primordial earth, find a way to self-organize into the first, fragile sparks of life? It's a question that touches upon the deepest mysteries of existence. We're talking about a transition from mere chemical reactions to something that replicates, that evolves, that adapts. It's like watching a vast, silent ocean, and then, out of the blue, seeing a single, perfect seashell form on the shore, a testament to an unseen, organizing force. The scientific journey here is one of trying to understand the precise conditions, the subtle nudges, that allowed this incredible leap to occur. So, perhaps this tendency towards order, this spontaneous emergence of complexity, isn't just a curious byproduct of physical laws. Perhaps it's a fundamental aspect of the universe's very dream. A deep-seated inclination, woven into the fabric of reality, to move from simplicity to complexity, from randomness to intricate design. It's as if the universe itself is dreaming of becoming more, of organizing itself into ever more sophisticated and beautiful forms, a cosmic gardener tending to an infinite, evolving garden. It's a bit like a pile of sand, isn't it? Left to its own devices, it's just a chaotic heap, a uniform expanse of grains. But introduce a gentle vibration, a subtle rhythmic pulse, and suddenly, the sand begins to dance. Intricate, ordered patterns emerge, delicate ripples and dunes forming spontaneously, as if guided by an unseen hand. It's a beautiful, tangible demonstration of how a little bit of energy, applied in just the right way, can coax order from apparent chaos. If the universe dreams of self-organization, if this is a fundamental drive, then we're left with a profound question. What is the ultimate form this cosmic dream might take? What is the grandest, most intricate pattern the universe is striving to create? As you move through your day, I invite you to notice these quiet miracles of self-organization all around you. Look at the delicate, branching veins of a leaf, a miniature map of nourishment. Observe the perfect geometric precision of a crystal, each atom placed with unimaginable accuracy. See the spiral of a seashell, a mathematical marvel born from simple growth. These are not accidents, they are whispers of the universe's ongoing, beautiful, and deeply organized dream. We've journeyed through the universe's molecular ballet, its silent symphony, and its potential for conscious dreams. Now, as we stand on the precipice of this vast, quiet expanse, we can't help but wonder, what is the enduring message woven into its very fabric? It's a question that whispers on the cosmic winds, a gentle echo in the stillness. And perhaps, the most profound message is one of interconnectedness. Think of it like this: every single star, every swirling nebula, every tiny dust mote dancing in the void, and yes, every molecule humming with its own quiet energy, is fundamentally linked. It's not just a matter of gravity, though that's a magnificent thread, it's deeper. It's as if the universe itself is a single, colossal organism, and we, in our fleeting existence, are but a single, vibrant cell within it. Every atom in your body, it said, was forged in the heart of a star, making you literally stardust, a cosmic kin to the most distant galaxies. This isn't just poetry, it's the elegant truth of shared origins, a testament to a universe where separation is an illusion, and belonging is the fundamental state of being. And then there's the astonishing possibility that consciousness itself is a cosmic phenomenon. Not some accidental spark that flickered into existence on a small blue planet, but rather, a fundamental aspect of the universe, as intrinsic as space and time. Imagine the universe not as a cold, indifferent void, but as a vast, dreaming entity, and consciousness is its ongoing thought, its unfolding awareness. It's a mind-boggling idea, isn't it? That the very act of experiencing, of perceiving, of being aware, is not a localized event but a universal current, a gentle tide that flows through everything. We might be the universe's way of experiencing itself, its own eyes looking out at its own magnificent creation. This leads us to the profound beauty of mystery. We've asked so many questions, haven't we? And the universe, in its quiet wisdom, offers not always definitive answers but more often, deeper questions. And that's a gift. Because in the unanswered, in the not yet understood, lies the fertile ground for continued exploration, for wonder, for the sheer joy of the journey. The universe doesn't owe us a complete explanation. It offers an invitation to lean into the unknown, to embrace the ambiguity, and to find a quiet, profound peace in the fact that there is always more to discover, more to marvel at, more to dream. And what is this universe's dream, if not ongoing creation? It's not a static picture, frozen in time. It's a dynamic, ever-evolving tapestry, woven with the threads of countless molecular interactions, of stellar births and deaths, of galaxies colliding and coalescing. Each moment, the universe is dreaming itself into existence, creating new forms, new possibilities, new expressions of its boundless potential. It's like a painter who never stops adding to the canvas, each brushstroke a new star, each shade a new planet, each subtle blend a new form of life. This eternal act of creation, this ceaseless dreaming, is the very essence of its enduring nature. The quiet universe isn't empty, it's a vast, silent canvas upon which billions of years of molecular dreams have been painted, and countless more are yet to emerge. It's a cosmic gallery, silent but teeming with the echoes of what has been and the vibrant promise of what is yet to be. As we drift towards a gentle close, consider what is your part in the universe's enduring dream. Feel the quiet hum of existence within and around you. You are a part of this grand, unfolding dream. And so, we've journeyed through the silent expanse, haven't we? From those fleeting, quantum fluctuations in the vacuum, like tiny whispers in an infinite room, all the way to the intricate, slow dance of molecules that gather and coalesce, forming the very stars that light our night sky, the planets beneath our feet, and indeed ourselves. We've felt how the fundamental forces, like invisible threads, bind them all together, how atoms gather like shy dancers, and how these molecular interactions, these subtle nudges and pulls, give rise to the very consciousness that allows us to sit here, together, and ponder these deep, quiet mysteries. The universe, in its profound, almost unbearable quietude, is really a symphony of molecular potential, a vast interconnected web of what we might call dreaming entities. And what does it truly mean for molecules to dream? Perhaps it's not a dream in the way we understand it, with images and narratives, but rather the inherent potential held within them, that gentle, persistent drive towards organization, towards forming something more. It's in their subtle, almost imperceptible communication, and in those emergent properties that hint at something far more profound, something beyond just the sum of their parts. In this quiet universe, we find that even the smallest, most unassuming particles participate in a grand, cosmic narrative. Our own consciousness, born from this incredible molecular ballot, is truly a testament to the universe's boundless capacity for wonder. We aren't just passive observers gazing out at the stars, we are integral threads, woven into the vast, dreaming tapestry of existence itself, reflecting its quiet, breathtaking beauty and its infinite, unfolding potential. As you carry this sense of cosmic connection with you, perhaps a little spark of wonder, we invite you to share your thoughts. What aspect of this journey, this exploration of dreaming molecules in our quiet universe, resonated most deeply with you? Did the idea of these fundamental building blocks, holding a form of potential, a quiet dreaming, spark any new insights for you? Please share your reflections in the comments below. Your participation truly enriches this space, making it a more vibrant and connected experience for us all. And now, as the stars begin to truly twinkle in your mind's eye, let this contemplation gently guide you into a peaceful, deep rest. Allow the quiet, steady hum of the universe, that subtle vibration we've felt tonight, to lull you into a deep, restorative sleep. May your dreams be as profound, as intricate, and as deeply connected as the molecules we've explored together. Sleep well, and until next time, may you find endless wonder in the quiet,